already. So levels of organization. So if you remember Unit 1, we discussed mostly of the cell. So right now, Unit 2, we're already in the level of the tissues. So you know already that the tissues are composed of several cells that act as a unit to do a certain function. Then you know that when group of tissues combine to do a specific body function, that's already have the organ, then a group of organs, the system, and then eventually we have the organism. So basic tissues that we have to discuss in this unit. So we have actually 4. So first is the epithelium, which we'll be discussing today. We have the connective tissues, we have the muscle tissue, and lastly the nervous tissue. So our next topic, this is actually in order already how we're going to discuss it. So epithelium will be our topic today. Next week we'll have the connective tissue, and then the proper and also the specialized. And then later on we'll discuss the muscle tissues also. Okay, so this is important. I think this is in your lab manual, if you went through your lab manual already. So these are the 4 basic tissues, and then their germ layer origin. So we have the endoderm, mesoderm, and ectoderm. So what is important to note in this topic, especially in your book, the derivatives. So just remember that the connective tissue comes from the mesoderm, muscle comes from the mesoderm, nervous, because you remember neuroectoderm, so it's in the ectoderm. Then epithelium would have 3. They would come from both the endoderm, mesoderm, and the ectoderm. And then, so I think this is very familiar if you read the book. So the derivatives are being enumerated here. So it's very clear, and I think this is one of those that you have to give a little more time because you would have to remember, as pointed out in our ISGB, it may come out as a question in your practicals, as the second question. Aside from identifying, we might ask you what is the germ cell layer that specimen was derived from. So as a correlate also with this topic of germ cell layers, will correlate with mature teratoma or dermoid cyst. So there's also a topic there in your book. Read on it. It could be asked in a question. So in histology, as was pointed out by Dr. Camiging, I think in your previous correlates, was that in histology you have to look at tissues and your slides at the various views, so objectives. So first, it would be advisable if you really look at your slides, your specimens, from the scanning to the low to the high objective. Okay, because you would have to identify and see how it looks like from that general perspective to the close-up view of it. So this would help you also determine, it will give you a clue. For example, we're pointing to a structure. The surrounding tissues could be a side question, or they could be clues to what is the structure being pointed to. So for example, in this one, this is the renal pyramid, and then this is in scanning. Then if we go to low power, you can see already that there are renal corpuscles, the nephrons, glomerulus. And then on high power, you would already see the cells themselves. So for this topic with the epithelium, most of our views are already in the low power or high power objective because we will be pointing out more of the epithelium. So for this, we would be concentrating with regards to the Bowman capsule and also with the proximal tubules, which we will be pointing out later on. So epithelium. What are the general characteristics? It's also in your manual, made up of cells with scant intercellular substance. They rest on a basement membrane, the lamina propria, with in between there's the basement membrane. Then we have, it is avascular, meaning you wouldn't be able to see the vessels in the epithelium, although you would see the vessels already somewhere already in the lamina propria. So by diffusion, they would also be supply nutrition and other substances that they would require. And then, but they are supplied by vessels, by nerves, because as we will discuss later, there are some functions with regards to neuroepithelia, so they would need receptors for that function. They may also undergo metaplasia. So we'll go through one by one each characteristic. So scanty intercellular substance. So you can see the epithelia. This one is an illustration. This is the actual slide. So with regards to, as you can see, per cell, there's really very limited intercellular substances. And then you would also see that there is a lamina propria. So from here, in the illustration, it's actually between. Then here, this is the lamina propria, or the connective tissue. And then there is it rests on the basement membrane. Okay. So this is in H&E preparation, this one. So, but usually the basement membrane could sometimes be, during preparation, it may not be very visible already, especially with the usual H&E staining. With regards to, I mentioned in avascular, so you can see in between the cells there is no blood vessel. But I think there are some in the connective tissue that you can see. It's already below. I just want to show this because I want to differentiate basement membrane and the basal lamina. So usually you would refer to the basal lamina when you're looking at what do you call this, views, instead of the usual H&E staining, because here you would already see the structure. So this is actually part already of the renal, actually this is the lumen of the, and this is the endocyte and the lumen of the capillary, and then this is actually the podocytes of the, so these are the podocytes already of our Bowman's capsule epithelia. So if you can see, this is actually the filtration barrier of the renal corpuscle at EM view. So this is a close-up view, this is the basal lamina. You can see the podocytes, the endothelial cells. So let's discuss, we mentioned about they may undergo metaplasia. So what is metaplasia? When we convert one type of epithelia to another type. So it's actually an adaptive mechanism, response of the cells to stress, chronic inflammation, even infections, abnormal stimuli. So if you can see from here, this one is the abnormal, this is the metaplastic cells. So if you can see here, they started as columnar, I think. And then here, they are already stratified squamous. So important to point out with the topic of metaplasia, there are some examples mentioned in our book with regards to chronic smoking. What would happen? They would may develop squamous cell carcinoma. Maybe, I think this is the one. And then there, with regards to chronic HPV infection, the survey, cervical carcinoma. With, for example, chronic exposure to stomach gastric acids, with GERD, with gastroesophageal reflux disease. So they would, the esophagus would develop into Barrett's esophagus. So those are the things that are important to remember. Correlate what are your topics with clinical manifestation in clinical cases. So you would appreciate the importance of the topics that we are discussing. So when we say it's a reversible process, so if you remove the stimulus or the stressors, so they would eventually reverse back. But if this stimuli would persist, they would develop those that we mentioned. Usually it's carcinoma, which is what we are afraid of. So let's just touch on the topic of epithelial tissues. So examples that were given was that of the Leydig cells of the testis. So if you remember, epithelium is defined as cells that would have the characteristics of epithelial cells, although there are some manifestations which are not appreciated in our tissues. So, for example, with regards to the Leydig cells of the testis, The cells are, neighboring cells are in close contact to each other, hence we are considering them as epithelial-like cells, but they don't have a free surface. If you can notice, this is the capillary disease. So this is actually LC supposedly, or interstitial. So the Leydig cells, you cannot appreciate any lumen or any free surface area, and then they don't also develop from a free surface, so they are mesenchymal derived. So what are mesenchymes? So they are embryonic connective tissue, and then of course they are endocrine in nature. This is another example, that of the islets of Langerhans. So they are found in the pancreas. They too are in close, the cells are also in close contact with each other, but you can see also there is no lumen, there is no free surface that could be appreciated. So they develop also from the epithelial cells by invagination instead of coming from the mesenchyme, unlike that of the Leydig cells previously discussed. But they are also endocrine with prominent capillaries. So most of the examples that were given, if you will notice, they have endocrine functions. They are endocrine in nature for epithelial tissues. So the general classification, so we usually name our tissues based on the number of layers and the shapes that we could appreciate. So for the number of layers, there's the simple, pseudostratified, stratified. Actually, the transition is a stratified tissue. So the shape of the cells with the squamous, you would describe it as having bigger width compared to its length. With cuboidal, more or less they approximate width and length. With regards to the columnar, greater length than the width of the cell. And then the transitional, this is a special tissue because they would just change in appearance or morphologically depending on whether that organ is distended or non-distended. So we'll be showing you samples of the slides later on. Then with specialized, sometimes you would name them, for example, stratified, columnar, simple columnar, then you would have ciliated, non-ciliated. So the specialization of the cell for a specific function would have additional classification. You say whether they're ciliated, they have keratinized, not keratinized. Then if there are presence of glandular tissue, and neuroepithelia is if they have mechanoreceptors or some receptive functions. So let's go through one by one each type. So we have the simple squamous. So examples of them are already enumerated, and then they serve as a barrier. They also help in the exchange and lubrication. So this is actually the simple squamous epithelia at surface view. So if you can see from here, the serrated border, the close approximation or apposition between the two cells, and then this is the serrated border among them. So this is the simple squamous. So this is one example, the vascular endothelium. So if you can see here, this is your blood vessel. So these are the cells lining, inner lining. If you can see, the nucleus are somewhat flattened out, and then the cells are big in width but short in length. Okay. So this one is actually, don't be confused that this is inverted. Actually, if you're looking at actually at the mesothelium, so this is the serosa of our intestines. So if you can see here, the clue would be that you have the inner circular and outer longitudinal, and this is the lining or the mesothelium. So the serosa outside. So as we mentioned, mesothelium is also composed of simple squamous cells. And then I showed you earlier also a bigger picture of this. So lining the Bowman's capsule for simple squamous epithelia. Then we have the simple cuboidal. So they serve for absorption, conduits, barrier also, and they may have some secretion functions. So this is a sample of the renal collecting tubules in longitudinal cut. So if you can see here, the lining in your tubules, the width and the length of the cells are somewhat similar. Approximately, they are the same with circular nucleus inside. So, and it's only one layer. Don't be confused with this. This is actually other tubules in other views. So this one is just simple columnar. I think I'll show you another picture. Okay, this is the thyroid follicles with colloids inside. So you can see around it, per follicle, you would see one layer only of cuboidal cells. So simple cuboid. Then simple columnar. So they serve also as for absorption, secretion functions. So this is still a renal collecting, but instead of previously tubules, this is a collecting duct. So if you can see here, they may look similar to the previous, but if you look at the cells, this is it's actually standing up. So it's not the basement. You always have to remember that your basement membrane is somewhere here. So this is your length and this is your width. Always determine the location of your basement membrane and where's the loop. This is the free surface of your cells. So you know that this is the length, this is the width. So if you can see here that the length is longer than the width of the cells, and most of the cells, if you can see here, they're more oriented to the basal location. So simple columnar. This is another example. This is the ileum with goblet cells. So you can see here, these are the goblet cells, the one pointed out by the arrow. So they too are simple columnar, as that most of the cells are basally oriented, and you have a longer in length than in the width of the cells. I think this is clear. There's only one layer of cells, and then the nucleus is somewhat oval in shape, and then the length is it's longer than its the cells are longer than in comparison to its width. So if you can see here, the cells are just one layer. With regards to your pseudostratified, so they are actually single layer cells, but they may appear several layers because the nucleus may not be in one single straight line like unlike the pictures we showed earlier. So they may appear multi-layered, but actually they are single because they're all attached to the basement membrane. They're all close to the basement membrane. So if you can see here, this is the trachea. So if you can see, a clue would be that there is a cartilage. This is actually a C-shaped cartilage. I just showed you a portion of it, and then this is the close-up view of this epithelium here. So you may be shown part of the cartilage to determine that it is the trachea that we are showing you, and then you can see here, it may look as if it is stratified because of the different locations of your nucleus, but they're actually only single layered. And you can see here, there is the cilia. So it is a ciliated, pseudostratified ciliated columnar epithelia. So if you can see, how would you distinguish it from the stratified? If you remember when I said columnar, most of the nucleus are in the bottom. So if you can see here, it's somewhat clear. There's no nucleus that's appreciated here. Okay. So this is another example. So this is the epididymis. How do you know that it's epididymis? It's usually the spermatozoa. So if you see the C-shaped cartilage of the trachea, that's already a clue for you. For the epididymis, you can actually see the spermatozoa in this slide. So for this is also pseudostratified columnar, but instead of cilia, it is posterior cilia. So there, if you can see, it's longer compared to the shorter cilia located in the trachea. Then we discussed the stratified squamous. So the usual slide that is shown is that of the skin. So if you can see here, This is what I mentioned earlier, the keratinized stratified squamous epithelia of our skin. So there are several layers of the skin. You can see there are still cells even at the close to the apical portion. Then it's prominent also in the basal membrane area. And then they kind of become bigger when they're already here at the middle, and they flatten out, and eventually you cannot appreciate anymore the nucleus, and you will later see the already keratin in the topmost portion. This is another example of stratified squamous. So this is found in the esophagus. A difference with that of the skin, that is the lack of the keratinization. So this is non-keratinized stratified squamous epithelium. And then another example is that of the vagina. So it's still stratified squamous. Then stratified cuboidal. So they serve as a barrier, a conduit. So examples. So this is the sweat gland. So you can see stratified cuboidal because there's more than one layer. So this is one layer, this is another layer. So actually here you can see two layers for the duct. There's sweat gland ducts. So they're cuboidal because more or less the length and the width are in close approximation, and also the cells there are somewhat circular. I just have to point out the interrectal junction. If you can see, there's a stratified cuboidal here. You can see it here. So the cells, the nucleus are here, this one, the one with the stratified cuboidal because there's more than one layer. But as you can see, the nucleus is somewhat circular, and the length and the width are also close approximation. So we will show you again this slide in the next topic, the stratified columnar. Actually, if you can see here, this is simple columnar. It's only one layer, and the length is bigger than its width. But you can see here from this transition from the columnar before it becomes stratified cuboidal, you can see already a layering similar to this illustration, wherein there are cells below it that are somewhat compressed because there's another layer of columnar cells which you could appreciate. So you would name them columnar because the cells on the free surface are columnar in shape. You wouldn't say that these are cuboidal. These are just they're the layers below the columnar. So, but they are actually columnar cells. They would just not appear as much as they would appear like columnar cells in certain tissues when you're already looking in the microscope. But actually, they are columnar cells. So they are stratified columnar cells. So this is still the anorectal junction. And transitional epithelium. If you notice, this is the urothelium. So you may find it in renal calyces, the ureters, the bladder, and the urethra. So they serve as barrier, and they have distensible properties. So that's what we mentioned earlier. So this one is actually the stratified. It's stratified because there are more than one layer of cells, and then they would have various appearances depending on if the state of if the organ is distended or non-distended. So these are transitional epithelium. So they are usually flattened when the organ is fully distended, and they would become, they may be cuboidal, they may be a bit columnar when they are non-distended, depending on this organ. So let's discuss cell polarity. So cell polarity, we've been mentioning earlier, this is the apical portion, this is the basal portion, this is because you would have to orient yourself each time when you're looking at slides of the epithelia, which is the area of the basement membrane, or if you're looking at EM, basal lamina, and then you're looking where is the free surface or the apical portion. So for this cell polarity, I think this one would best illustrate it. This is the apical domain, basal domain, and then we have the lateral domains here. The ones between two cells opposed to each other are the lateral domains. So those are the three domains of the cell. So first, let's discuss about this free surface specialization. So more of the apical domain. So we have the microvilli, stereocilia, and the cilia. So I think you know already from, there's a summary in the summary table in your book that the cilia has the mobile primary and the nodal type. So first is that of the microvilli. So it's short, as you can see, 1 to 3 micro, and then they are bundled actin filaments. So if you can see in the cross section, they're just actin filaments there, and then they are anchored into the terminal web. So this is the terminal web, and then their motion. So it's just more a passive movement, and then the function and its location. So in the next few slides, I think what you would have to give emphasis with regards to these structures are location. So example, where they are found, how they differ from each other, with regards to the structures themselves, the important ones that would have a significant role with their movement, or what makes them different from other structures. So those are the ones that you would have to give emphasis in. So we'll not go into detail with regards already to the specific proteins because there are several. It will really take us a very long time if we're going to discuss each and every one of them. But we still, it may still be asked in the exam, but not in that much detail. But the important, that's what I mentioned. You still have to remember those proteins which would have important roles with regards to its function, how it moves, how it differs from another free surface structure. So those are the things that you have to remember. And then when we say microvilli, you're able to tell us where they're usually found, then how they differ from the stereocilia. Is there a certain protein which is in the microvilli which is not present in the stereocilia and other structures? Those are the things that you're supposed to remember. Okay? I won't expect you to give me all of those, because there are really several of them, but you have to read it. Maybe not memorize it, but understand how each and every one of them would help in the overall function of the structure. So for this, you can see, we have here already the brush, this is the brush border of our kidney tubules. What do you call them if it's already in the intestines? Then there's stereocilia. If you remember earlier, we had another picture of epididymis, but there were spermatozoa inside. But you can still appreciate the stereocilia here, so it's still a clue to you that this is the epididymis. So they are longer than a microvilli, and then they would more or less have a similar appearance as they are more actin filaments. And then remember the location and the function. Okay, so the cilia. So I mentioned there's the mobile, the primary, and the nodal. So what do you have to remember here? I think we will discuss the mobile because this one has a clinical correlate with a certain condition. But you also have to know about the primary and the nodal, which is found in most cells. Okay, so if you can see, it's written found in almost all cells. And then you would have to remember how they move, certain motion specific to that structure. And then this is an important structure also is for the motile cilia. So we'll give emphasis on the motile cilia. If you can see here, so this is the cilia of our superstatical columnar epithelium of the trachea. So you can see the 9+2 pattern. Remember, 9+2, 9 times 0, 9 plus 0. Okay, what is the 0? There are no microtubules inside in the middle. Unlike that of the motile cilia, you have this pair. Then keratinize, we mentioned earlier, or about the keratinization of the cells, especially in the skin, of epithelial cells of the skin. So here I think we have to discuss about cell renewal. So there's a cell, what we call cell turnover. So for the skin, usually it's 28 days, so more or less a month. You can remember there is the stratum basale here at the bottom. So it's also called germinativum. So they would undergo mitosis and provide cell renewal. So cells will go up. They would be more prominent in shape and circular. As they go up, they will be flattened. They may have keratin already, so you would lose their nucleus in the appearance, and then later on keratinize, and later on slough off. And then this is in comparison to our small intestine. Cell renewal is only 4 to 6, but of course you would know that there is no keratinization in that area. So lateral domain. Okay, so we have, what are the important things that you have to note in the lateral domain? So at the very top, we have the tight junctions or the zona occludens. Below it, you have the zonula adherens, and then I think it's here, this one, the macula adherens, or what you would also call as desmosomes. So that's another name for it. So you can see the tight junctions or the zona occludens, and then the zonula adherens, macula adherens, or the desmosomes. So those are the ones that are found in the lateral domain of our cells. What do you need to know about these? I'll show you a table, then we'll just point out the important stuff for those important structures in the lateral domain. With regards to the basal, you have two that are important. I forgot to mention about the gap junctions previously. Here, there's the gap junctions here. So they're also called nexus. Okay. So for the basal domain, we have the focal adhesions and the hemidesmosomes. So I think we have a table here. So the table would show the differences. So as I mentioned earlier, it's like this also. For example, the difference between hemidesmosome and desmosome with the other structures. The cytoskeleton compound is more intermediate filaments compared to the other structures would have active filaments. So that's an example of how you have to give emphasis on these tables and all those structures and all those parts that are being illustrated in your books. So know the difference between them. So that's an important thing because it would differentiate the desmosomes and hemidesmosomes compared to the others. And then with regards to major link proteins, just the important ones with clinical or significant functions to regards to clinical cases or possible examples I will be citing. And then, of course, you would have to know whether they're the lateral or the basal domains. Okay, so these ones are the ones in the basal domain, the focal and the hemidesmosome. And then, as I mentioned earlier, the gap junction or the nexus. So we're already in the glands. So with regards to the glands, we have exocrine versus endocrine, and of course paracrine.